record. So we're live. The notes are in Slack. Yeah, so let's maybe just start with a bit of a roundtable, see where people are at. John, would you like to start?
Yeah. Yeah, sure. Yeah, nothing too much on development side. Mostly some stuff internally. I'm making an app so it makes it a lot easier for everybody to run SimPEG inversions, and just kind of like a UI that talks to some of our resource computers in Saskatoon and spins off inversions. So that's a ton of fun.
Nice. And is that like a Qt app or?
Yeah, I'm just using Qt pretty much for the whole back end, the Qt SSL stuff and most of its network tools, and yeah, just a little Qt interface and just C++ in the background on the resource manager side.
Cool.
Yeah, yeah, I finished off the first round of the AI stuff. That was pretty cool. Thanks for the recommendation of going to PyTorch. Yeah, that's definitely the one to use.
Nice.
I've got it up to 95% accurate, and it's, yeah, chewing through databases and picking out all the bad signals. And yeah, it's pretty cool.
So what exactly is the problem that you were applying to, John?
We were just trying to minimize, I guess, what time wasted on processing. Like, it'll try and process files that are obviously just disconnected and just, yeah, nodes that were malfunctioning. So what the problem was is just weeding through that so that we could just produce a subset of the data that is going to produce good enough data to process, not waste any time on all these other kind of nodes. And yeah, it seems that, like, yeah, sometimes the nodes have, like, the network will kind of go shaky and then it'll turn, the node will turn on to record. So yeah, I'm quarantining at least like 40% of the database, so I'm saving quite a bit of time.
Is that the IP data or the MT data? What data are you?
Just for DCIP right now is that I've got it going.
How do you train something like that? What are you using for good data, and how is it? Yeah, what's your training set?
Pretty much, I went through I just like grabbed a whole bunch of time series and I made my own classification step. So I went through and just like, or I look at it by the full period, and yeah, I'll just like, this one's EM affected. I took data that didn't have multiple things wrong with it in a sense. So it was just like, this is EM coupling. There's not going to be like poor contact or anything in there. Just found data that really highlighted those classifications, and yeah, just made a database of full time period signals, so that then you can look at when the whole signal was processed through the AI. If like 50% is good and 50% is bad, you know that the node got disconnected or something, and just little stats like that go through.
But are you actually classifying it as to, okay, this has got EM coupling, this has got poor contact, or this has got various different things, or are you just trying to get what you consider to be good data from other stuff?
No, it's pretty much, yeah, just classifying it as, this is EM coupling, this is a coupling issue, this is contact issue, and this is not telluric, sorry, like transient. Yeah, just kind of classifications like that. And then we have like a sampling issue that sometimes comes up, and I've taught it to find that as well.
So it's like do you have a good data category as well? So like you have good EM coupling, blah, blah, blah. So what happens if you got a whole bunch of them? Let's say like there's some set portion of data where you got EM coupling issues and harmonic issues and a whole bunch of them. Is that like I don't know, like, is that at least like a pick? It is noisy, or what's happening for that?
Sorry, like if it has all that kind of stuff in it?
Yeah, yeah, because I think when you're like applying your training sets, like when you're applying your classifier, you don't really know, right? Like it's just the data, right? Like it could include a whole bunch of them together. So it's not like not as nicely separated as, oh, it's like this is EM coupling, this is like harmonic. So
I tried to find the ones that were mostly like safe enough to say that. And so like, yeah, I tried to minimize ones that had combinations, like, oh, this is a sample issue and EM. And then I was looking at some of those stats. I haven't gone too deep into it, but yeah, like ones that have, say, like a sampling and an EM, if you look at the scores, you'll see that it is registering in both of them. It just depends on how you pick it. If you want to, you can go look into the scores individually, or if you just go for the max, yeah, whatever pops out wins, or the one that's the highest wins, kind of thing.
So that's interesting, right? Because you're training on separate issues, but
Yeah,
they're kind of additive at the end of the day.
exactly. And
That's interesting.
it was kind of cool to see. I haven't dug in too far into it, but yeah, it is coming up like that. So you can start, yeah, just looking at the scores of everything.
But at the end of the day, what you really want is like basically binary, right? Like a good or bad. I think at the end of the day, at the very end.
Yeah, I'm kind of just doing it most. At the end of the day, it's just good and bad, and that's kind of how I do it. Like EM coupled, I will include that in the good database, but it's just for statistics. Like at the end of it all, it'll say, well, you know, we think this has been 48% of this data is got EM coupling, and this one's bad, or this one had that. Yeah, mostly just classified so that I could get some information out of it. But at the end of the day, you're right. It's just good or bad.
Yeah, but it's great to have the statistics, I guess.
Yeah, it's something to look at so far.
Yeah, cool.
Sometimes maybe you want to just try to extract those that really do have significant EM coupling and just work with those.
Yeah, exactly. And it should have a good idea. And it does seem to be, it seems to get confused sometimes with the GDD transmitter because it's on time spikes right away. So I get that one called as a EM couple right away, but I think I might be able to teach it out of it. We'll see.
That's interesting.
That's super cool.
It's your child. You made it.
Yeah. My baby. It's finally alive.
Are you going to write it up in an abstract or anything like that?
Eventually, once I get things going again. Yeah, now it's kind of put onto the back burner. I really want to get onto this MT stuff, and then yeah, this app for the inversions. So those are going to take over for a bit. But once I get it going again, yeah, I'd be interested in abstract or something.
All right. Any other points, John? Okay. Cool. Thibaut.
Yeah, nothing really new in terms of development. Still working on that paper. Like I'm sorry. Like I'm kind of doing the figures at the same time. So for Doug and Dom, I'm like I will be able to send something by the end of the day.
Well, happy multitasking.
Yeah, I'm sorry about that.
No worries. No worries. Sagi, how are things with you?
Doing pretty well. nothing particular update for the SimPEG update. I was helping like I helped a little bit, you know, right? Like Ryan Smith, he's a professor at Missouri Tech. So he's one of the alumni in the Rosemary's group. So he's trying to use the cylindrical code to simulate the karst example. So they have like what they call totem system, and then I think he butted. So he butted, and they are basically trying to characterize where the cavities and the characteristics of the cavity. So he wants to use the SimPEG as a simulator and do a machine learning about what it's like. So you can generate a whole bunch of simulated data where you have like different size of the cavity, depth, different resistivity, and you learn that and potentially estimate what are the depth of the cavity and the resistivity of the cavity or something like that. So yeah, that seems an interesting application. I think people are moving on that direction more and more. So use so they recognize, oh, the field data is not enough. So we're going to use the simulated data and then train it and see if you can get the right answer. So that's seems interesting. And the other thing that I was collaborating with the topographic effects in the airborne EM data. So USGS guy, I think it's Paul Bedrosian, and one of his colleague named Katrina. So they got the airborne data from San Andreas Fault. So this is an interesting location because it's quite conductive. So even if you got like a big topography, if you are in a relatively resistive area, so it's not that much. So, but if you are actually in the conductive area, So that topographic effect could kill your 1D inversion. So this is an interesting example that they kind of faced, oh, their 1D inversion like simply not quite working well. So so we used the UBC 3D code to invert that, just the high moment data. And that was quite promising. So yeah, I think they want to move on and then do a bit more analysis about how much topographic effects that could be generated. So yeah, I think that I was using the UBC 3D code. I think I mentioned it before. Yeah, that's on my end. So nothing really particular for SimPEG. Things are moving on.
Well, it's cool that they're using it in Missouri. It'll be fun to sort of just keep track of that and get a sense of what their results look like.
Yeah, I'm looking forward to it. Yeah. So he seems like he sort of figured out the time domain, how the time domain code works. So it seems promising.
Excellent. Well, Dom, do you have updates or anything?
Yeah, we're just working on the potential fields UI for SimPEG and Analyst. I'm actually pretty excited about this. It's nice to be able to invert a tree on rotated meshes and do both grav and mag pretty quickly.
Nice.
And I'm working on a directive because right now, like the MVI code was running, Cartesian first, the linear part, and then it would be, a whole bunch of script to switch to a spherical. So now I'm trying to write a directive that will do the vector inversion all in one go and just do the switch internally. So we don't need to have like a clunky code. And then all the iterations going to be in order, right? So that's what I'm working on right now.
Oh, cool. Yeah, I'll be curious to see what you come up with there. Doug.
Nothing particularly from my end, except that, yeah, I've started to get to write the extended abstract for the SCG. So GWB will have a workshop there. And we have an opportunity to present at least a couple, and I'm going to talk to the new gal. It's Talibi, I think is her name. Anyway, she's taken over from Linda Ford. I've got a scheduled phone call with her tomorrow. I just want to find out what this workshop is, or that presentation session, and see what kind of flexibility there is. But at this moment, certainly we can present one paper that just talks about the GWB project as a whole. The paper that I'm just trying to put a draft together on actually has the role of open source in capacity building. So we've got actually a really, really nice story to present from that perspective. I'm going to talk to this gal tomorrow, but I think there's perhaps another possibility to actually talk about the developments of codes and SimPEG algorithms for doing simulation and inversion, and really kind of taking this down to another level. So effectively, there might be like 3 levels. Like one's just at a high level for what the project was, and then the second one really focusing on where open source plays a role, and it's everywhere from the slides in the course website, and capturing the videos, as well as all of the Jupyter notebooks and case histories. I mean, how that really is kind of the glue that allows people to communicate, and reproducible results and all this stuff. So that's sort of at an intermediate level, but there is potentially, I think, another level that's farther down that really is talking about the codes that are developed in SimPEG and distribution of them through Jupyter Notebook. So anyway, that's kind of where I'm at, and depending upon the meeting tomorrow, I think we could kind of follow up and see how we want to position SimPEG and all the stuff that we've been doing with respect to the GWB project.
Excellent. Well, I look forward to hearing how that conversation goes.
It's like a day workshop, Doug?
I don't know. Actually, I don't know. The GWB has something every year, and I'm not sure what they're planning for this next year. But basically, they used to just focus on all the projects that they were funding, and people would come and talk about them.
I see.
And yeah, so we'll see tomorrow what they've got in mind and what kind of flexibility there is. And so I'll contact you guys right after that.
Okay, well, sounds great.
Anyway, that's it for me.
Yeah, thanks, Doug. Yeah, the couple of updates that I have, got an email from Alexander, who's at Aurora Geosciences. They're wanting support for getting ELF inversions in SimPEG. So again, somebody else who wants, natural fields EM up and running, and a few more examples and things like that. They're willing to actually pony up some money for that. So I don't know if there's anybody who's sort of actually in a position where you'd like to sort of take on a bit of contract style work. Like, we could probably scope that so that it's something where you are just responsible for generating a few examples. Because I mean, there's enough of us who want to do a push on MT and natural fields. Like, you don't have to be rewriting everything. But if somebody sort of wants, a contract style position, that's something we can absolutely do, I think. And if not, I think there's still like opportunity to connect with them and loop them in and actually try and sort of get them engaged in actually creating examples. Which would also be a good thing. And I don't think that those two things are mutually exclusive.
I was looking back through the emails, and I never saw a place where they actually talked about dollar values. Do you have any sense of what they were referring to?
No, so they didn't actually provide a dollar value, but they've asked, they'd like to know if they could pay somebody to get ELF data inverting in SimPEG. So I imagine like a contract style position where you could bill by the hour kind of thing. And we can absolutely like schedule a call to get a sense of that if that is of interest. I think we should schedule a call with them probably either way, but it would be good if we can sort of figure out, is this something that somebody wants to sort of put on their plate a bit more formally, or is this something that we just kind of work with them informally?
Because at some point, I mean, we might want to scope out beforehand, what the functionality and the capabilities of our MT code are going to be, because for the ELF data, it's basically tipper data, right? So it's vertical over magnetic field at the particular location, and certainly all thoughts about what our MT code would be would definitely have that, as well as whatever combinations of transfer functions you might want to think about, as well as, well, they're not measuring electric field, so it's basically just EM, like Z-temp type of stuff, but depending on where you put your reference receiver. But I don't know, it might just be worthwhile for us as a group just to kind of scope out, what we'd like to see in that MT world. And as I said last week, then Dequan was also kind of interested, and just sort of figure out where we might want to go and who's interested, and then see how Aurora might fit. But certainly they would be probably very good from the point of view of providing data sets, and they might also be a really good group to test things. I mean, if things were set up so that they could just go ahead and run, then it might be a very nice way for us to kind of interact with them and get some examples.
Yeah.
Well, this is where all the labor is, right? Is to set up something that is usable.
Yeah.
That will require time investment by someone.
Yeah, and if you have somebody who knows the data and they've collected the data, then they're in a much better position to do that. And that would be very beneficial for us to have some examples done and to interact that.
Oh, John, I think you might be muted.
Oh yeah, I'm sorry. They reached out on discourse there, and they posted a line of data. I was gonna get to it, and I did reply back saying that like, well, yeah, this will be easy because I've already been doing some Tipper Ford modeling. They would just need to build a loader for their data, and that was where it just kind of fell off. So I'm judging from this, I feel that there's nobody there that has Python experience is what's happening.
Okay.
They just need someone to really build a loader. And what's interesting there is I'm kind of in the process of doing that too with our data that we just had or got back from South Africa. So I'll be building pretty much an IO in a sense that it's similar because they're not using EDI files either. They're just using a text. So I guess I would be happy to rehash my code if they really needed it, kind of thing.
Is it weird is there a weird spot for you since you're kind of two contractors?
Yeah, it is kind of weird, but I think at this point, like wouldn't matter. It's going to be like it's open source, so it's not like we were trying to hide it anyways. And code is the code, and it'll run the same way. And I'm loading the files pretty much similar to how they'll be doing it. So it's just getting their format and putting it in.
Yeah.
So I got no problem with it. Again, like you said, it's just going to take hours, and those are coming few and short between here in the next little bit, but doing what I can.
We could think through that, John, too, is like potentially even laying out basically what are the steps that they would need to take. I mean, if there's already sort of a template that they could build from, and if none of us have the bandwidth to really do that, a couple of us basically helping like shepherd them figuring out how to just write a simple Python loader file.
Yeah. Might
not be a bad idea. Is like, to get some investment from them on the table. If it's not cash, it's time, somebody's time.
Yeah.
Would it be worth, and I think this is sort of on the radar, but having a just dedicated MT natural fields meeting to sort of just start planning some stuff, like either later this week or early next, and sort of hash out a bit of a plan, because it seems like this is something that is kind of burning for a number of us. And so getting some details around that might be helpful. Do you think this is kind of the right time for that, or do we want to wait a bit? I don't know what people's thoughts are on that.
What do you think, Dom, from our side? I don't know how long they're going to go back and forth seeing if they can give us dedicated time or a collaboration, but should we start looking at it or wait until we get more feeling?
I think so. I think we should just start doing it. So next week's a little bit it's a bit bad for me, but if we maybe the week of the 13th, if we could schedule at some point a meeting there.
I believe that could be good.
We could, I guess, after the meeting.
Any sort of a document started? Somehow I think we did, with respect to, the MT code and what its current status is and what kind of functionality we want to have and how we're going to read, what the data format is going to be, and just all of the kind of the details of trying to decide, what the SimPEG MT code would look like.
Yeah, so we started that Google Doc that I sent around sort of for the Jupyter planning, but it might be worth actually turning that into like a bit of a discourse post. Would that make sense? Do you guys think? And we can iterate on that a bit, just so it's a bit more in public, and we could even point some of the folks like Aurora to it.
Yeah, it's up to you.
Okay, I can start something like that, and I think you can do it like a wiki, so anybody can sort of edit like the main text, so that we don't just end up with like a giant thread. I'll try that. If it becomes too clunky, we can just move back to a Google Doc and just like leave a Google Doc link in the discourse post. I think that's also totally fine.
What is your time frame, Lindsay, for your postdoc? You said you needed to deliver some empty stuff right before the end.
Yeah, so with the Jupiter Meets the Earth project, we need to deliver, well, we need to deliver basically scientific use cases. And so I pitched the MT use case. I'm going to Paul Bedrosian actually and get some data from him to play around with. But basically what I need to get out of this for the Jupiter Meets the Earth project is some like concrete sort of development tasks and or things that are somewhat unique to the Jupyter ecosystem. So for example, we now have a Jupyter Hub developer sort of, he's on 2 days a week at this point on the Jupiter Meets the Earth project. And so one of the things that we're looking at trying to get an understanding of is a problem like MT, does it make sense to be running it on the cloud? And so we have access to cloud resources, and so playing around then with SimPEG on the cloud and sort of comparing that then also to, we also have access to the NCAR supercomputer, Cheyenne, and just kind of like getting a sense of what sorts of things could be improved and perhaps what sorts of things could be streamlined so that if I only have access to Cheyenne, but I send it to Sagi and Sagi's got access to the cloud, is that basically as seamless as possible? So I think there's some interesting questions on that side of things to play around with. So I sort of need to provide like Jupyter development tasks and then also demonstrating how those tasks have enabled new science. But I specified that like in the space of MT.
So there's seems like 2 levels, right? Like there you have at the higher level to handle the how to handle the cloud resources, but you also have a lower level problem in the code, how that could be like parallelized or structured to be run in that system. I guess is that like are you trying to handle both of them, Lindsay, or like you're more on to the upper level structure?
So I guess my interests are more on the well, there's a bit of both, but on the SimPEG side of things, that's where I plan to be investing effort, but then in conjunction with working with folks who are on the Jupyter Hub side of things and can help me and can help us figure out what's the best way to parallelize and all of that sort of stuff. I mean, with Dask, we should be portable to both locations pretty easily, but that's something that we say verbally, but you never really know until you actually start hitting on these things. So yeah, does that answer your question?
Just curious.
Yeah, that's great because if you can figure this out with that project, then that will answer a lot of questions for the rest of our stack, right? How easy it is to do distributed memory parallelization.
Yeah.
Because it's not clear how scalable it is right now with what we have, the way we have it structured.
Yeah. So I'm just kind of curious, who's really championing this MT code? Like, because there are 2 levels, right? Like, there could be a level of like computation, like, oh, how we're parallelizing this and make it really efficient. That's one side. But on the other hand side, we need to make sure the physics works and like that the boundary condition, like there are lots of details about like setting things really right, and then test like with the like more realistic data, such that like, oh, that code really works. Do we have like I don't know, like who's really do we have somebody really championing this? Because it's somewhat distributed at the moment, and I'm not sure who's really kind of pushing this this MT code development. So
I can just kind of add a little bit of something. So this is where Joe is now spending a lot of his time and effort. So I talked to him yesterday, and that he's really focused on getting into the MT problem, really trying to understand how it's coded, how to work with the boundary conditions, and get into the physics. So I think from the point of view of working and developing a code so that we can change the physics and the boundary conditions or things like this, I think Joe has the potential for playing a real central role. And since he at this point is really the only person who has got a mandate to kind of work within that SimPEG environment and get paid for it, you know, it kind of works. So I think that if the rest of the group we can kind of get together and really decide, you know, what we want to have as a final product, and try to see what bits and pieces are around, because everybody perhaps knows something that is going to be of use, but actually to have Joe being, you know, a real key point in this. At this point, from the people that we have here, I think that's sort of the logical way to go forward.
That sounds great, Doc. Yeah, that'll be awesome.
And John and I's plan right now is to have our respective companies pony up man hour of our hours to do this, but more on the, you know, on the usable side. So if Joe can handle like the testing and all that stuff, that's great. And then John and I can look at more of the usability of it, parallelization with Lindsay and whatnot.
Yeah, that's great. Yeah, I'm more interested in the physics part and setting the boundary conditions and that types of stuff. Like that's actually quite interesting. So I'm happy to help, but I was just thinking about that. I just don't have enough time to really jump in and push through. So
well, I think that's true with everybody who you know, is on this screen at this point. Got, you know, a primary mandate, and then trying to fit in, you know, SimPEG development or MT or something like this as it coincides with what their projects are, so that you can kind of kill two birds with one stone. But nobody has got really time to say, oh, okay, here is my main project, and this is what I'm going to do. So I think that's where, you know, the benefit of having Joe is really important.
Yeah, and then it's great. He's really good. So,
and especially since he's not signed into this meeting.
Exactly, we'll just sign him up to do all the work.
I'll let him know after.
Yeah, sounds good.
He's got no choice now.
Yeah. Oh, excellent. Okay, well, yeah, let's plan for something then. We said the week of the 13th.
Yeah, that'd work good.
Okay. In the meantime, I'll try and basically put what notes I've taken into a discourse post, and we can sort of try and work asynchronously so that we've got a bit of a document to start from that week. Does anybody have a preference on day? The week of the 13th? I can put together like a little poll if that's easier, but if there's one day that we decide works, that would be nice to know.
What time at 13th? Is that the same time?
Or that week.
Yeah. I'm open.
Give me 1 sec. I'm just looking at the.
Yeah. For Monday, I have a meeting at 2, but other than that, I'm good.
Tuesday onward, I'd be good.
Tuesday.
Anytime.
If we did like Thursday, maybe for a couple of hours, would it be all right to block a couple hours for this?
Yeah, that's probably a good idea. Yeah.
Okay. Any preference on morning versus afternoon?
Okay, so sorry, I have a weekly meeting at 1 on Thursday. Usually it's an hour. Is that okay if we do it at 2?
Sure.
Thursday, 2.
Thursday the 16th, starting at 2 for 2 hours.
That sounds good. I can.
April 16th, yeah.
Works for me.
Perfect. Yeah, 2, that is 3 here. I'm still now have to do all the minutes.
Yeah.
There we go. Okay, perfect. That sounds good. Well, and we can double check that works for Joe, and from there.
Sounds great. Perfect.
Excellent. Any last burning? Oh, what were you gonna say, Don?
No.
Any last burning questions, ideas, things before we?
Be at peace.
All right. Take care, everyone. Stay safe.
Yeah, stay safe.